from what I've seen before when we were trying to do these word problems, the hard part isn't finding that answer, especially for easy examples like this. The hard part is writing those word sentences as algebraic expressions. Right? Would you guys agree? Right? That's probably like the hardest part about it. It's like almost like translating something. I will show you some tips on that in a moment, but I do want to say that, when we look at simultaneous equations, right, don't just think about arbitrarily finding x and y. People actually use equations like these to solve real problems, and it will ease our way into this. The hard part, again, right, is when you're just solving simultaneous equations, what you're doing is step 2, right? That's what you're normally used to. You're just given the equation, and then you need to solve for it. The hard part is step 1 and 3. In a real world application question, you don't get given the expression, you have to create it yourself. And then also, you actually have to answer the question that you're given. You actually have to answer the question. Mick, could you read out the first one for me?
There are 620 students in school. If there are 80 more girls than boys, how many boys and girls are there?
Okay, so again, like one of these like riddle word problem kind of things, it's a bit of a step up from these ones on your sheet here. This is why we, rather than guessing and thinking about what numbers work for this, we want to create these equations, right? Maybe if you had enough time, you could answer it by trial and error. But again, right, the harder these problems get, the harder it will be to answer just by trying to guess the numbers. So I just want to be clear about what's the problem here. I know in some school, I've got 620 students, that's fair enough. But I also know that there are 80 more girls than boys. And I want to find out how many girls and boys there are separately, right? Again, I just want to think about my first step. I want to create some expressions. In order to do that, though, I need to introduce some variables. I need to use variables now. So what would be some appropriate letters? I could just say, let G equal girls. And let B equal boys, yeah. Okay. Now let's just think about what I actually know about these variables. I know that there are 620 students in the school. So what could I say about my girls and boys in terms of an algebraic expression? Say that again, sir.
G.
Exactly right? I know that there are 620 total students. I know that there are girls and boys. So if I just add them up together, or G plus B, that will give me the total number of students. That would just be 620. But what about the other part of my equation? That one's a little bit trickier. I know that there are 80 more girls than boys. So are there more girls or are there more boys?
More girls.
There are more girls. Okay. So what was that? G equals to B plus 80. So G equals to B plus 80. So because there are 80 more girls than boys, if I add 80 to the number of boys, that should give me the number of girls, right? Does that make sense? There are 80 more girls than boys, so I know there are more girls. So I say, hang on, if I take the number of boys that I have and I add 80 on top, I should get the number of girls as well, shouldn't I? Does that make sense, guys? Any questions about that? So all I've done here, I've created two equations. I know that my G plus B, that should give me the total number of students, that's 620. But I also know that there are 80 more girls than boys, so B plus 80 will equal to G. It's really important that's actually the hardest part. Because once you do step 1, now you've just got those two simultaneous equations. Flynn, can you remind me again, when is the best time to use substitution that you wrote down? Do we have that in this case? Yeah, I've got that G is equal to B plus 80, don't I? So I can think, hang on, well, if G equals to B plus 80, I can go back to this equation. And I can just use that substitution method, right? I can say sub 2 into 1. So all I'm going to do is I'm going to say, hang on, instead of G, I can just write B plus 80 here. So I'll say B plus 80 plus B would equal to 620. That's all I'm doing, right? I'm taking what I know from this equation, that G is the same as B plus 80, and I'm putting it inside there. So here then you get 2B plus 80 equals to 620, and then you can just rearrange to solve it, right? Okay. So 2B, it would equal, take away 80 from both sides. What would that be? That would just be 5, what's that? 540? Yeah. Yeah, 540. And then last step, Jade, how can I get B as a subject here? What do I need to do?
Divide by 2.
Yeah, divide both sides by 2, right? 260? Yep. 260.
No, 270.
270, yeah. Cool. And then with simultaneous equations, right, we're always interested in both variables. We don't just want to solve for one, we want to do both of them, right? So I've got what b is equal to, so I want to sub it back into one of my other equations. Which one would be the easiest one, do you think?
2.
Yeah, right? Because if I substitute it into there, I don't have to worry about rearranging it at all. I can just put it straight back in. I would say sub b equals to 270 into 2. Yeah, so you just get g is equal to 270 plus 80, so that would equal to 350. So you can see, we're going through these 3 steps here. Anytime we have a worded simultaneous equation, we want to use these steps because the more complicated they get, right, the more that this is going to help.